In this video, we will finish up our program and then do an example. So in our last video, we kind of finished all the necessary logic. If you wanted to optimize this program, you could go ahead and add if-then statements to get rid of things when there's no information. So I'm going to go ahead and delete all my yellow cells to show you what I mean. Like you have divide by zeros and a bunch of zeros over here. If you wanted to, you could always logic those out by saying if a cell equals 0, comma, quotation, quotation, comma, the actual equation you want to execute. So if it's not there, then nothing. If it is there, then the actual equation, the something. So essentially, this program is making you check for 4 things. Number 1, you would need this z of x to be larger than this z of x. The z of x of the member chosen must be greater than the actual z of x of the moment applied. That's 1. Number 2 is the shear strength must be greater than the shear applied. That's logic test number 2. Number 3, the actual deflection must be less than the allowable for dead and live. And then number 4, the actual deflection must be less than the allowed deflection for just the live load. I'm going to add one more thing, and I'm going to call this just kind of the catch-all. So I'm going to just say the chosen steel member works true or false, question mark. And I'm going to do a new programming function, if you want to call it that. And I'm going to call it the AND. And AND does a bunch of individual logic tests all at one. And if they're all true, it'll say true. If any of them are false, it'll say false, which is exactly what we want here. So first one is if this is greater than or equal to this, that's good, that's true. Then if the shear strength, we want greater than or equal to the applied, comma, we want the actual deflection. Actually, let's do the other way. I want the allowed deflection to be greater than or equal to the actual, and then I want the allowed live load deflection to be greater than or equal to this. Gives me the divide by 0 error message, which is fine for now. And I'm going to do that. And I'll make this like, I don't know, this, because this is like the true ultimate everything else. Like at a quick glance, you can tell if this is working because it will only be a true design if this cell says true. Okay, let's do a scenario. Let's say that the beam is 24 feet and that the dead load is 10 and the live load is 15. Boom. Just like that, I have the max moment, max shear, and the actual moment required and the shear applied. That easy. Z of x is still not there because you have to tell it. So let's say this is a 36 steel. So the f of y is 36. Boom. Now I know my z of x right here. E is 29 million. It'll always be that for steel. And now I know that I need to choose a member. Okay. So let's go to that website, which I don't remember the website, so we got to find it in the PowerPoint. Steel sections, W flange, and I'm going to be looking for the lightest steel member that'll have a ZX of at least 82.5. So we're going to go to properties, lightest member of 82.5 or more. So the lightest W16 is W16 by 50. Lightest W18 is W18 by 46. (21 by 44 would work. That's even lighter, so we're getting better. And the lightest W24 is already heavier. So my answer is going to be W21 by 44. So I'm going to type in over here. Oh, that shouldn't be that way. I wanted only these two cells. I don't know when I made that mistake, but this is supposed to be yellow. W21 by 44. I think that's what I said. Okay. And now that I have that, I'm going to type in 95.4. And the I, while we're here, is 843. So it was 843 for inches to the fourth. And 95.4. And then the thickness of the web and the diameter, or the depth, would have to be all the way at the top. Go back to dimensions, scroll back down to 21 by 44. 20.66 and 0.35. 20.66 and what's it? 0.35. Boom. And this works. How do I know it works? Well, we were required this much z of x. We gave it this much z of x. We were applying this much shear. This is our strength of shear. Our allowable deflection is shown here, and this is our actual deflections. We have good, good, good. This works. It's all true. Now, what if this did not work? What if it worked for a moment? Because it's always going to work for a moment because you're choosing the one that does work. And then we found that it failed for deflection. What would that look like? Well, let's just change up some numbers. Let's just pretend that the inertia of this member was 300. Ooh, it says bad. And over here it says false. Then over here, it realizes, you failed deflection tests for both dead and live and just live. And then it'll give me the maximum of these two to know what my redesign is. So this required it's telling me, okay, 300's too low. You need to choose a member that has an inertia of at least 357. Then you would go back to here, go back to where it says properties, and choose a member that has at least the ZX that you need, but also an I that is greater than or equal to the inertia that the program told you. So you had to choose one that was at least 357.5. So one that had a ZX of at least what you need and an I of at least what you need. And then you find a new one, blah, blah, blah. And then you find that the new one has, the ZX of whatever, the thickness of whatever, the D of whatever, and the I of whatever it was. And you'll find that one's going to be greater than 357. And you'll find that it'll work then. So you will only ever need to change up your member one other time. Like, you should never be testing more than 2 members per problem. You do your first one. If it doesn't work, the second one is guaranteed to work if you are following these steps. And once you have this, this design is valid. So let me go back to the actual numbers. This right here, this is your work. You take a screenshot of this, and this is telling me that you fully designed this problem. So you can go over to snipping tool, copy it, save it, call it, Q1 if it's question 1, and then submit it on Google Classroom. So the way I'm thinking for this problem, this homework, is you are going to be you'll open up the Google Doc, wherever the questions are. I'm just going to open up a blank one, but you would have your actual one. Super quick. And then you're going to go to snipping tool. Lightning fast right now. I'm going to go to new. This. And instead of saving it, let's just paste it. This was question 1. Blah, 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 blah. You would just paste it right here. And then type, W21 by 44. If you had a beam that did not work, I want to see it. So say, for example, I'm just making up numbers because it did work the first try. But if you had something that did not work, like say you did W18 by, 40, and that did not work, tell me, show me this screenshot. Take a screenshot of this, which did not work, paste that first, and then afterwards, and when it does work, give me that one as well. So don't forget to take a screenshot after it failed, because once you fix it, you're not going to get the original one. So give me both. I want to know what failed and then what worked. And that's how you will do the submission for this one. All right, that's it for programming. Hopefully that wasn't too bad. And you guys should be proud of yourself. Like, what we just did here is awesome. We just made our lives easier by letting the computer do our difficult work. We created a program that will design the right size steel beam given a load scenario. I don't know. Very few people at this high school or at the high school level across the country can do that. And I don't know, you should give yourself some credit for that. Be proud.